So this is problem 941, and calculate the centroid of the Frustum. It's a truncated cone where the tip is chopped off. So a cone, peaked like this, that's revolved, and when you chop it off, that part goes away, you're just left with the frustum. So it's a right circular cone with a portion, the upper part's been cut off. All right, now they have this given in the coordinate system like this. So at the origin is in the middle of the base that's revolved, and it goes to the middle of the top. And they have the x-axis, the y-axis, and the z-axis. This is going to be revolved around the z-axis, can you see that? Like a little area that cuts out, comes down, cuts, and is revolved around the z area, gives you that cone. So the cone has height h. The cone has radius little r at the top, and the cone has radius big R on the bottom. They asked us to find the centroid z bar. Now, they didn't ask us to find x bar and y bar. Why not? Symmetry, they're equal to 0. You're getting so good at this, right? Symmetry, they're equal to 0. To find z bar, first I want to calculate the volume by the integral of dv. If I can do that successfully, then I go back and I modify and I want to calculate z bar is equal to 1 over the volume. Sometimes I put a v like that. I'm sorry. Sometimes I don't. Leave it alone. Try to be consistent. Okay. 1 over the volume times the integral of z dv. Is that our two formulas we want to do? All right. How do I calculate the volume? That's the first big task. I want to turn it into one-dimensional, where I have disk that I sum, like stacks of disk. True? That's integration, 1D. So is it going to be stack of disk that are in like this? Like that? Yeah. So I say the disk has a height dz and an area a. So the volume I bust into the integral of a dz. What is a? A is of that disk, but the disk area is a function of z, is it not? This area is pi. I'm going to call it a for lack because I used cap r and lowercase r. A is some radius of the disk. So pi a squared will be the area of that disk times dz integral. A is just a function of z. And when a is equal to 0, I better get back cap r. And when a is equal to h, I better get back lowercase r. And the way they've shown it on the illustration, the cone has just straight slides. That the blue line is just straight. So it's not that hard, but what do we get? We get that a is a function of z. It starts at cap r, and it goes down to lowercase r if I travel a distance h. There's a number of ways you can get that equation. Is that a good equation? Does this equation work? Does it check for here and check for there? It's just a straight line, right? Okay, now I just have the integral of pi times a, which is r plus lowercase r minus cap r, z divided by h, all of that squared dz, and I'm going to integrate where z goes from the lowest at the origin, 0, to the highest, which is h. This volume is 1/3 pi times h times r squared plus r cap r plus cap r squared. Well, now, once we have that done, We come over here, and I know that this, I don't want to erase this, so I'm just going to leave it like this. And I want to do this integral, z bar. Well, z bar is equal to 1 over v. I'm not going to repeat it, but there it is, all down there. Now I integrate z dv. Well, we set it up so it's just going to be z times pi times cap r plus r, lowercase r cap r z over h, all of that, squared dz. Guess I should have scooted that down. And when you do that, dot, 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 don't you love it when it's dot, dot, dot? Like you have to fill in all the steps and work. You pick up that it's equal to h times 3r squared plus 2r cap r plus cap r squared divided by 4 times lowercase r squared plus lowercase r cap r plus cap r squared. So that's z bar analytically.